Okay, students, in section 10.3, titled Formulas in Three Dimensions, we're going to learn about Euler's formula, about the distance in the diagonal of a right rectangular prism, and we're going to learn also about finding the coordinate points in a three-dimensional coordinate plane. Now, first of all, we need to know what a polyhedron is. And a polyhedron is a solid formed by four or more polygons that intersect only at their edges. Prisms and pyramids are polyhedrons. Cylinders and cones are not polyhedrons. Poly means many, hedrons is sides. One of the formulas that we need to make sure we memorize is Euler's formula. Now, who is Euler? Well, Leonhard Euler was an 18th century physicist who developed this formula and also many other concepts that we now use in modern mathematics, in geometry, in trigonometry, in pre-calculus, and in some other areas. Okay. Now, the formula that he developed, it's a V minus E plus F equals to 2, where the V, it's vertices, E is the edges, and F is the number of faces. Like for example, here we have a triangular pyramid. The number of vertices, it's 4, 3 on the base and 1 up here on where all the lateral faces intersect. So that's 4 vertices. It has 6 edges because it's 3 edges on the base and 3 on the lateral faces. And 4 faces, 3 on the lateral sides and then 1 as a base. So when you substitute the numbers, 4 minus 6 plus 4, 4 plus 4 is 8, minus 6 is 2. So 2 is equal to 2. And this is how you verify Euler's formula, okay? So if we go to problem number 1, in number 1 it says find the number of vertices, edges, faces of each polyhedron. So number of vertices, well, I have 1, 2, 3, 4, and then 5, 6, 7, 8 from the top. So that is 8. How many edges? The edges are 4, 1, 2, 3, 4 on the base at the bottom, and then 5, 6, 7, 8 from the top, 9, 10, 11, 12. So it's 12 edges. And the number of faces? Well, the faces, it's a flat surfaces. So we have 2 bases, so those are 2. And then we have the face on the front, on the right, on the back, and on the left. So it's 4 on the lateral sides, and then 2 bases, that is 6. And then the second part says, use the results to verify Euler's formula. So when I verify the formula, which is V minus E plus F, and that's supposed to be equals to 2, and I substitute the values. V is 8, E is 12, F is 6, and the question is that equals to 2? Well, 6 plus 8 is 14 minus 12, that is 2. So you're going to say 2 equals to 2, and then you put a check mark. So that way you verify that the answer is true. 2 is equal to 2. Okay, now you try problem number 2. Go ahead and try number 2, please. Okay, the answer is supposed to be V is equal to 6, E equals to 10, F is equals to 6. The formula, V minus E plus F equals to 2, 6 minus 10 plus 6 equals to 2, 6 plus 6 is 12, minus 10 is 2, so it checks. And that's how you verify, okay? Next, let's go ahead and check the formula for the distance between two vertices in a polyhedron. And the formula is D equals the square root of L squared plus W squared plus H squared. So as you can see, this is the length, this is the width, this is the height, and this is the diagonal of a polyhedron. It could be like this, it could be like this, it could be like this, or it could be from this point to the opposite side. Okay, so if you want to find the diagonal length, we use this formula. This is kind of like the same thing as a formula for the Pythagorean theorem. Pythagorean theorem is the square root of a squared plus b squared. So this is kind of like the same thing, but now we have a third dimension, okay? So let's try problem number 3. It says find the unknown dimension in each figure. Round to the nearest. We're not going to round to the 10th. We're going to round to the hundreds. So change that, please, to the hundreds. So in problem number 3, it says find the length of the diagonal. So we're looking for the length of the diagonal. And if you recall, the formula was distance equals square root of L squared plus W squared plus H squared. So if you're looking for the distance of the diagonal, all we have to do is put all the dimensions. And they're giving us a 6 by 8 by 11. So this is like if we have a rectangle, we connect those dimensions. So this is like an 8 by 6 by 11. So it's a three-dimensional, it's a polyhedron. So what we're looking for is the diagonal length. So from one corner to the other, okay? Kind of like the opposite corners. So all we have to do is just put the numbers in the formula. So the length is 8, so it's 8 squared, plus the width, 11 squared, and then plus the height, 6 squared. And then just put all of that in the calculator. So put that in the calculator, please. So the distance is supposed to be 14.87 centimeters. Okay, now go ahead and try problem number 4. Set it up and then we'll continue together. So set up the equation for problem number 4. Okay, so when you set up the equation, you're supposed to have 9, because that is the diagonal. 9 equals 4 squared plus 5 squared, and we're looking for the height. Okay, we're looking for the height. So when you're looking for the height and you're solving for the height, the first thing you need to do is put parentheses around both sides, left and right, and let's square both sides, because that way we can get rid of the square root. Okay, so, and on the left side, 9 squared is just 81. And when you combine 4 squared plus 5 squared, that is 16 plus 25, and that is 41. And then get rid of the 41 by subtracting 41 from both sides, and that is 40. And then you get the square root of both sides, because the opposite of squaring is the square rooting. So put the square root of 40 in the calculator, and the height is approximately 6.32. The unit of measure is inches, so it's inches. Okay, that's problem number 4. Okay, so now let's go ahead and move to the second part of the lesson.